Hey, welcome everyone. I'm Bas, and this is my colleague Koen, and we're both founders of AI development agency SevenLab, located in the heart of Amsterdam. And today we're excited to talk to you about a technology that's revolutionizing business around the world. And in particular, that's artificial intelligence, or AI. And in the next few minutes, we'll explore what AI is, how it works, and most importantly, how it's transforming various businesses and industries. And from automating routine tasks to providing deep insights from complex data, AI is already reshaping how we do business currently, and we'll do that even more in the future. And we'll show you a few real world examples that we have been working on and discuss the potential impacts, both positive and challenging, that AI is bringing to the table. And let's dive into it and see how AI is not just the future of business, but also very much part of the present. I'll share my screen. Koen, do you have anything to say before we start the whole training?
No, not necessarily, no.
Okay, then we'll dive right into it.
Let's go.
We'll start off with a quick outline of the things we're about to discuss. So first of all, we'll do a quick recap of what we do at SevenLab and why we are the people to talk about this. And I think as a software company, we're in the unique position that we can also show you how this technology AI is currently being applied in various business processes and industries. Then we'll dive into some theory with Koen. He will explain us the underlying mechanisms of AI in general, and we'll dive into a couple of models that are currently available on the market. Then we have some examples for you, so concrete business cases of how this can be applied in your own organization. And then we'll see what you can do as a company or business owner to start with AI. So that's it. Well, first of all, a quick introduction about SevenLab. We've been developing software for 16 years already, and the last 2 years have been mainly focused on AI. And these are AI applications in particular. So we're not really developing new models. There are currently billions being invested in developing new models, but we use these models to bring the technology to end users. So we build applications you can interact with. These can be chat applications, web applications, or just AI agents that act in the back end of a certain process. Yeah, that's our specialty over the last 16 years, and we're applying that to this new technology to bring it to the end users. Let's see where AI can help. Before we start all the theory, we want to know which business processes could be where it could be applied beneficially. So what we see in practice is that AI or Gen AI is being applied in these 5 different aspects of a business. So first of all, we see a lot of opportunities in the service and support business, and we'll dive into it a little bit later, how this can be applied exactly. But what we also see in a lot of inspection work or control work, there's also a lot of opportunity to automate things with AI. We have the data processing and analysis part of a business where this technology can really help. We have knowledge management and content creation. So when you're looking to apply AI in your organization, you should mainly look at these pillars because the most important business cases are located in these areas of the business. And we'll show you a little bit later in the presentation how we have done this for several clients to give you an idea and some inspiration of how to do this on your own. Okay, let's dive into a concrete example in that case before we dive into all the theory. So I just talked about the knowledge management process that's relevant in a lot of organizations. And I want to show you one quick use case here that we recently did for a customer, Move Beyond, a big IT strategy consultancy organization. And they had this problem that they had all these consultants with a lot of knowledge about IT strategy. And it was kind of hard for them to share that knowledge between groups of consultants. And then we had a quick discussion with them, and we ended up with the idea to basically build two AI agents. One AI agent we built specifically to gather knowledge from employees within the existing communication channels they were already using. So they were using Microsoft Teams on the work floor to communicate between consultants and within the organization. And we built an AI agent that would ask the consultants to share a little bit of what they're doing currently at a client. And the AI agent has been instructed to ask as many questions as needed before it deems that it has enough information to actually save the knowledge in a common knowledge base. And then on the other hand, we instructed another AI where users can ask questions about the knowledge that has been built by all these consultants together within the entire organization to get the information they need from that knowledge base. So they need to handle a specific case, for example, at a specific client, and then they can ask the AI a question, and it will use all its built knowledge to provide an answer to that question. So when, for instance, a consultant shared a best practice about rolling out a particular system, like let's say an ERP system at one of their clients, then the AI would know about past use cases and use that context to give them an answer about the best practice right away. So yeah, that's an example up front. And now we'll dive into the theory with my colleague Koen. So hit it off.
Yeah, let's go. Yeah, let's just first start with a quick look at the status quo of AI right now. There's a lot of talk about AI in the news, of course. There's quite a hype cycle. Some people think AI is the problem solver for all their problems. And other people think AI is bullshit. So if you look at this overview, right now AI is in the phase of narrow AI. It's the lowest level of AI. AI is currently capable of handling real specific tasks in a process, but it's not able to take this knowledge of this process to another domain. If you look at all the investments done by the bigger companies, they are all aiming to achieve the general AI stage, in which an AI model is capable of taking this knowledge of a specific task. So, for example, the example Bas gave about knowledge gathering, to take this task to another domain and apply the same specifics there. So once we reach the level of general AI, or the models can operate more on their own, and do things in different settings at once. And then the third level is super AI, which is a far stretch goal in the far future, where AI will be able to, for example, run an entire company based on all the data and systems linked to it. So that's something for the future, but right now we're still in a narrow AI phase, but we are approaching the general AI phase.
Yeah, maybe a quick question about that, Koen.
Yeah.
So, of course, people might know ChatGPT, and
Yeah.
we'll get into that a little bit later in the presentation. But isn't that already using part of its domain knowledge into other industries than we were used to? Like, isn't it already transferring from one domain to another in a certain way?
No, I don't think so. If you talk to ChatGPT, you're talking towards a large data set of knowledge. But ChatGPT isn't capable yet to perform a specific task. You instruct it to apply it on its own on a different domain. So I think it's still really focused. If you look at ChatGPT in particular, it's really focused in answering questions you give it. But if you use this model behind ChatGPT, ChatGPT 4.0, for example, it's not capable of making its own plan to achieve a certain goal. Not at the level of a general AI stage would be.
Like a general AI could do everything, you mean?
No, not everything. That's more the super AI. It's a combination of creativity and intelligence. So at a certain point, these models get smarter than the smartest people on domain topics. But there's also creativity needed to come up with new solutions for problems. I think the combination of the two makes general AI or super AI. So right now the models are getting close to the smartest humans on domain specific topics. But I think when you have a model that's smarter on all domains of knowledge and the creativity, then it can come up with new solutions which we as humans aren't able to come up with.
Yeah. Okay. Thanks.
Yeah, when you look at AI in general, because a lot of people talk about AI, but they don't really know what AI is. If you look at AI is a field of study which has been running since the 1950s. It started with making machines compete in certain simple games, for example. And since the 1980s, machine learning came to. Machine learning is a set of models in artificial intelligence which can learn from data. We'll tell a bit more about that later. And since 2010, deep learning was founded. And deep learning is a subset of machine learning, and it uses multiple layers of processing data to learn from. So if you go to the next slide to talk a bit more about machine learning. Like I said, machine learning is about machines that can learn from data. We've been building software for 16 years now. And in the past, when we needed to process certain information, for example, analyze information, we would write a lot of rules to process this information, to check for certain specific details in this information. Nowadays, with machine learning, you can train a machine learning model based on a data set, a historical data set, to use it to predict future values. So if you go to the next slide to get some examples, you could, for example, train this machine learning model on a lot of data about the sun, the wind, and also the pricing of energy, electricity, to predict future values. So you train this model on the combination of sun, wind, and electricity. So it's learning the correlation between the two.
You mean historical data, right?
Yeah, historical data. And when this model is trained, you can then put in, for example, predictions or actuals, and then use this model to predict the electricity price for that certain point. The same techniques can also be used for pictures. So, for example, X-ray imagery can be used to predict certain diseases. You can look at gene data, but also the spam labeling in your email inbox. That's also based on machine learning. So there's a machine learning model that's trained on a lot of emails which are labeled spam or not spam. And using this machine learning model nowadays, we can mark emails as spam or not automatically. And the funny thing is that this machine learning model can be retrained constantly to make it better and better and better. Let's go to the next slide. Because if you look at deep learning is a newer form of AI. It's a subset of machine learning. And with deep learning, like I said before, they use multiple layers of neurons. It's a neural network to process information. So if you train a machine learning model on historical data, you need to tell this model where to look for. So please look for the combination between wind and sun in combination with the price of electricity, and then the model will learn. With deep learning, there are a lot of layers in this learning process, and each neuron in these layers looks for a certain specific of this data set. And it will trigger, for example, on the color red. And it will trigger from 0 to 1, where 1 is really red and 0 is not red. And all these neurons have their own specific to look for. And when you train this model, it starts to recognize patterns in the data without instructions up front. So if you go one slide further, if you compare the two different technologies, machine learning, which is older, it's easier to train a machine learning model. You don't need that much data, but there are accuracy plateaus when training these models. Also, a funny thing to note is these machine learning models are trained on CPU, so the processor of your computer, while deep learning models are trained on the GPU, the graphic processor of your computer. And that's why the stocks of NVIDIA, which is a GPU manufacturer, are skyrocketing right now, because all the big companies, the tech companies, they need to buy these GPUs to train their models. And with deep learning, there is an unlimited level of accuracy, but you need a lot of data to train these layers in a model. But it's able to relationships in the data on its own without instructions up front. Then if we look at the models, there are different modalities used in models. So if you look at a model, you can put in pictures, text, audio, video, and also the output can be pictures, text, audio, video, etc. So you have uni models that are trained on one specific modality. So for example, only pictures. So you can put a picture in and there comes a picture out. And you have multimodal models. GPT, for example, GPT-4o is a good example of a multimodal model where you can put in a picture and, for example, ask what's on this picture. Or you can put in text and ask, hey, generate a picture of a horse, for example. And that's also a distinction in the models that are developed right now. Some models are really focusing on a really specific modality and also a specific application. So they become really good in generating pictures, for example, for medical use. And other models are really focusing on this multimodal approach, which are the bigger models that are out there right now. So GPT-4o, again, as an example, is a good multimodal approach. It's one of the biggest models that's out there right now.
Yeah, maybe it's also good to note, right? When you're looking at this presentation, you should get just a generalized view of the AI space. But we're mentioning models here that are probably outdated like next week. For instance, we had already a lot of news this week, like Meta from Llama releasing their new models with also vision capabilities. We have Gemini from Google. There are a lot of these models out there and they're constantly evolving. So I think that's important to note here as well. And I think in a general sense, most of these companies are trying to build multimodal models. And I think that's because then it can answer almost any question, right? You can put anything into it and it will be able to answer you about that object, that text, that audio, that video. And the more types of data it can handle, the more it can be placed inside like your process, because you should think of it like a human being, right? That we also have multiple capabilities. We cannot only understand audio, we can also understand video from our eyes, and yeah, they're trying to replicate this into an AI. So
Yeah.
a little bit of context there.
Yeah, and I think it's also the combination of if you implement AI and AI can operate on its own, you want to make this implementation as easy as possible, and that would mean that it would act as a human. So that's why the figure 1, for example, which is a humanoid, a robot, is also really scaling up their investments and development right now. Because if you have a robot with AI brains, which can operate in normal life, it can take the bus, it can handle a machine, for example, it's far easier to implement than when you need to develop new machines because they can't be operated by AI on its own.
Yeah, or when they did it in the past, they were training like machine learning models that were only capable of executing certain tasks, So either recognizing an object or a set of objects, and then a separate model to calculate or predict which movements to make, for instance. And if you have everything in one model, yeah, you already have a great start to build something in the physical world.
Yeah. Maybe we should go on with the AI labs. Like you said, Bas, there's a lot of development happening in the deep learning scene of AI. Of course, you have Meta, the company behind Facebook, Google, Anthropic, Microsoft, OpenAI. They're all big labs that develop models. You also have Mistral. Mistral is a French company that's also building their models. And there's also China, of course. You have Baidu, and Baidu is one of the bigger companies there. And to give a bit of perspective, at OpenAI right now there are working, I think, 1,200, 1,300 people. At Baidu, at the AI division, 12,000 people are working right now. So the scale of their focus on AI in China is not comparable to the Western world. And if you look at ways to improve the results of your AI application, it all starts with data. So the saying garbage in, garbage out also applies here. If the data you hand over to your AI model isn't correct or wrong structured, then the output would also be less good as you want. The same goes for the technologies you use to set this up. A lot of people we talk to say, for example, hey, I'm using ChatGPT right now to generate text or to answer questions, which is a good starting point to learn how this technology works and to understand, okay, what's going well, what needs improvement. But if you set up the right combination of technology in the sense that you have the right data linked, you combine this with the right model, with the right settings, you can really improve the results you get from your application. And the same goes for the prompt. So the prompt is some sort of persona of the AI model you're using. So you tell this AI model you are a sales representative, you work for this company, your goal is to reach XYZ, you need to apply to these rules. So this prompt is really determining how creative the model can be, and also which rules it needs to follow. So it's also some sort of guardrailing the output process. And if you look at all the projects we do, I think the first three, so data, technology, and prompting, that's the main focus we have in each project.
And maybe in regards to the data part, like unlike the traditional AI, we are talking specifically here about Gen AI applications and improving results in Gen AI.
Yeah.
And where historically for machine learning models you needed really well-structured data, that's now less relevant. For instance, you can use like a dump of text to train a model, and in the past you needed basically an Excel sheet or a database with structured information. So in that regards, yeah, you can train on unstructured data, but still, like Koen said, if there are biases in that data or errors in that data, of course the model will try to find correlations within that data set you're using to train, and then also output the wrong answers. And the different providers that we saw in the slide before this are taking also different approaches to this data part. I think all the Gen AI companies that are building their models in the first place, they try to scrape as many data from the internet and then train their models with that and let the neural networks or the deep learning networks figure out the patterns. But you also have different companies that are sometimes also coming from, or different models that are coming from the big tech guys like Microsoft. You have, for instance, the Phi 3 models or the Phi models that are mainly focused on super high quality data. It be unstructured data, but really checked by everyone. So super high accuracy data that models are being trained with, and they're getting some very good results there with less data, but higher quality data, and then building small models from that. So they're taking that route. I think some of the providers that we saw on the previous slide are still like looking for the right amount of bad data and good data, and then just a small nuance there.
I think to give another example, Amazon, for example, is training their models also based on reviews of products on their website, which contains not always the quality of data you want.
Yeah.
But if you look at the projects we do, the first three steps, so data, technology, and prompting, is the main approach to improve results. And when you start working with an AI application, you also start with gathering more data. And this data can be used to fine-tune a model. And with fine-tuning, you take the model you want to use, and you give it a lot of examples of questions and good answers to fine-tune the model. And the good thing about fine-tuning is that the expense of the model goes down, so it's cheaper to use and also gets faster, and the quality gets better. So you're fine-tuning this model on a real specific application. So, for example, answering support questions for your company, for your SaaS company. But to do so, you need to have a data set of at least hundreds or thousands of examples of good questions and answers. And when you want to take it even a step further, you can look at training your own model. So you take a foundation model, some sort of base model, and then train it. But then you need a lot of data and also a lot of hardware to facilitate this training process. Then a comparison about using a model available in the cloud compared to a open source model. This picture is a bit outdated, but still all the projects we start with using a cloud model, because these cloud models are the top models right now that are available. And by using these more advanced models, we can also gather more high quality data for fine tuning in a later stage. So compared to a cloud model, you could also decide to use an open source model and host it on your own. There are a lot of different open source models in terms of how good they are at specific tasks, but also about their size. So like Bas, for example, said, Llama just launched a new version of Llama, their model. And this model has different sizes. So you can decide to host the biggest one, but it's also the most expensive to host. But you can also go for a cheaper version if you have a simple application of this model. So in each project, we tend to use the cloud version first, and then in the future, we can use the data gathered with this cloud version to fine tune a open source model and then host it on your own in your own infrastructure.
Yeah, I think now then it's time to dive into a couple of examples of how we've applied this whole AI technology that we learned about in the previous few slides, how that's being applied in practice. I think right now, since the beginning of this year, which is 2024, we've done about 30 or maybe even more Gen AI projects where we implemented this technology into production processes. And with production, I mean live processes that are currently running at companies where AI is assisting people to do different kind of tasks. So when we talk about AI, we can actually talk about 4 different kinds of AI. And in blue, we have the kind of machine learning AI where it's specialized to execute on one task. And we'll have an example of that later. Then when you look at generative AI, we usually say we are building application within these 3 pillars. So either interacting with your content, which means I have some data or I have some text or some documents or a knowledge base where I want to ask questions about to get direct answers. And for instance, this can come to life with a chatbot where the chatbot is connected with different tools, like it can be existing systems or, like I said, a knowledge base. And then once you ask a question, it's able to look into those sources and come up with an answer that's relevant for your query to the model. Then the second pillar is where we let an AI model look at some of that data from a certain perspective. So, for instance, we can have an AI model act like an accountant, a legal representative, a business analyst, and then give it a certain use case and then ask it to come back with a logical answer from that perspective. So this also applies in many use cases. We'll give examples later. And then the last one is content creation. So this is one of the things that people usually think about when using generative AI. So you ask a question to ChatGPT, for instance, and then it comes back with some content. This is mainly used to generate a letter, generate maybe courses or course structures, scripts, and write documents for you. And this also gets more interesting when you connect it also to your own data. So based on the data or knowledge you've built within your organization, you're producing new content, basically. So in the first category for machine learning, we have an interesting use case that we've done or that we've implemented for a Stichting Open, which is responsible for e-waste management in the Netherlands and a couple of other European countries, where they have the problem that they need to handle all these TVs that might contain mercury or not. And then in the past, it was really difficult for them to determine if a TV would even have this material inside. And they had a 15-step document, which they were using when separating the e-waste, or their employees were using when separating the e-waste, where they needed to go through before they could even determine if a TV had mercury in it or not. And what we built for them in the end is an algorithm that was trained on a lot of photos from TVs containing mercury. And then the end result was an app that could give a check mark or a big red cross when we thought the TV would potentially contain mercury or not. So they went from a 15-step document and checklist for every TV to an instant scan and result on if a TV would contain mercury or not. So big improvement, and also quite some time saved within the actual process of separating e-waste.
Maybe one question.
Yeah.
Sorry, one question about this case, because we use machine learning. Why didn't we use a deep learning model which is capable of processing images?
Yeah, that's a good question, Koen. Nice you ask. No, we are actually using a machine learning model here because one of the requirements was to have the model run on a device itself, so on a mobile device with very limited hardware capabilities. And when we were building this application, we didn't have the nice llama models, for instance, that were released just today that we're recording this presentation, where we had a multimodal generative AI tool where we could pass images to ask for a conclusion. And also the small Gen AI models are quite limited in accuracy, and we needed to and they're also used for general applications and not for really specific tasks. So we had a really nice specific task for the model here. We had the requirement to run the model offline on a mobile device. And we needed to be able to keep training the model to make it better and better with more and more photos for this specific task. And in that sense, we chose to work with a machine learning algorithm.
Is it then safe to say that in general machine learning models are on average smaller than a deep learning model? Smaller in the sense of the hardware it needs to run?
Yeah, they take less compute.
Yeah.
But like I said, recent developments in the Gen AI space, like the developments with the new Llama models that are the 3B models, they are made to be run on the edge, so on mobile devices as well. So yeah, the better these small models become, maybe eventually it will make the machine learning applications obsolete. Like if they can do calculations really well, object detection, and answer all those visual questions very well, then maybe for some use cases, Gen AI will take over.
Yeah. Interesting.
This is another interesting use case about creating new content. So we had one customer called Medic Invo, and they were creating self-help health plans or treatment plans. And these treatment plans were given to doctors to help their patients. So the doctor comes up with a treatment, and then he needs a document for the patient to read and to make sure they can do their self-care once they're no longer in direct contact with the doctor. And we help them automate that whole process with generative AI. So with a minimum amount of context, we can now create a full-fledged self-care advice or plan for a specific client or for specific protocols. And this is of course saving a lot of time in the actual process, because this whole company exists to make these kind of plans. Then we have AI support on a big company we did called Verhoeven. And with this project, we did develop a solution where we were connecting bread baking machines or the machine data with some knowledge about the machines of how to solve certain problems. So these were basically manuals for specific machines, and combined those two sources to provide factory workers with a direct plan of action when the machine was no longer working. So if the machine gave errors or was just stopping one of its processes, they would be able to ask the AI agent for a solution instead of a technician. So we saved a lot of time there, and we're also improving the accuracy of the answers given, and could also answer in the user's own language. So the level of the instructions, the difficulty of the instructions could be customized to the end user, but also literally in their own language. It'd be German or Dutch or English. And then we have a last one, so interesting one to compare to the previous solution. We had the AI model specifically trained to recognize mercury in TVs, but here we have taken a different approach for an AI vision model at a large logistics company called Loendersloot. They have a lot of incoming shipments, about 15 inspectors checking all kinds of shipments. In particular, they need to check for beverages. They need to check beverages for either customs or their end customers. And they need to enter about 150 attributes for every incoming shipment. And what we did is use a Gen AI, a multimodal Gen AI model, where we just feed it an image of an incoming shipment or a couple of images, and then ask it to fill in all those 150 attributes coming from a logistic expert role. And then we pass all that information directly into their ERP system. So, and this resulted in a mobile app where we actually take those pictures, analyze it with Gen AI, and then pass it on to the ERP system. Okay, so now we've discussed a couple of use cases. Like I mentioned earlier, we've done about 35 of these generative AI use cases and implementations this year. So we've only shown 4 here, but there's a lot more to talk about. But before we go into how you could try to use this technology within your own business, we would also like to tell you a little bit about the risks involved and what you should look out for when using this technology yourself. So yeah, now off to Koen again to tell us a little bit about those risks. Sorry, Koen, for letting you only talk about the theory and the risks, not the most exciting things,
not the sexy part of the video. Yeah, I think one of the biggest risks of applying AI is biased models. So these models are trained on really, really large data sets of text information found on the internet. This data is fed into the model to train it. These models are then tested by real life users who fine-tune the training process, and also these humans that are used to do this process are also biased, of course. So the danger is that you use a model to, for example, categorize people in a certain process, and this model has a biasness in it, which affects this categorizing of people. So there are certain steps you need to implement in building an AI application to check for this biasness, to review it while you're using the application, to prevent this from happening. And one other challenge of using AI is transparency. A lot of implementations of AI feel a bit like a black box. So you send in data and there comes an answer out, but you don't know on what this answer is based on. You don't know the reasoning of the model. So also on the transparency side of AI implementations, you really need to look at how you can lift up the hood of the AI application to see what's happening, to see where the reasoning comes from, and to check whether these answers generated are correct or not. And that also links a bit to the third risk of AI, which is privacy. When you send in data to a model, is this data stored? Is it used to train the model? When you talk about personal information, you don't want to send personal information to an AI model, which is then stored on their servers to retrain this model. So if you look at the projects we start, we always look for the biasness of the models we're using and how to test and prevent this. We look at ways to create more transparency so we can explain where an answer comes from. And we zoom in on the privacy aspect of the application to prevent wrong or unnecessary data sent to the model, which can be stored or not.
Yeah, maybe the perfect example of how this could result into something controversial is what Google did a while ago, where, for instance, you would ask it to generate an image from German soldiers in the Second World War, and then it would like generate only images of black people with Nazi symbols on the uniform. Because it was trained in a certain ways, and then in a different way than you would expect. So there was a little bit of culture baked into the model to present as many diverse a set of people within certain contexts, but like it has too much bias, or it was looking too much towards these aspects to generate output in these images. Might be fun to look those images up, and yeah, they're totally absurd, of course, but yeah, it works both ways. So the model is pre-trained with a certain vision of how culture should be, and then that also determines like the outcomes you sometimes get from these AI models. And for instance, the models from ChatGPT are trained in a different way than the models from Elon Musk that we didn't even talk about in this presentation. But Musk is building its Grok 3 model at this moment, together with all the data he got from X. And we all know the data on X is also, like in some cases, it's different viewpoints are shared than how maybe the people at Open AI are thinking about certain aspects of culture. So
maybe another good example: Amazon trained a model on a lot of resumes of people to use this model to assess new resumes sent in, to analyze the resumes before they did job interviews. But this model was trained on a lot of resumes, mainly from male co-workers. So apparently this model learned that male co-workers were better or preferable compared to female co-workers. So they, by inputting a certain set of data, this model became biased towards male profiles.
yeah, interesting. So we talked a lot about theory, a lot about the use cases, and what if you want to implement AI within your own processes and organization. This is usually the step we do together with our customers, where we try to do a big brainstorm together with a group of people about how this can be applied and what the biggest what the low-hanging fruit is when using Gen AI technology. But you can also do it yourself. So we would recommend the following steps. So first, assume the role of business analyst or I don't know, process analyst within your own organization, and then try to find something within the processes mentioned here that take a lot of time to execute on. So a part of that process. So for instance, when in the service and support area, you could think of use cases where we have to answer questions to people doing support requests, either by mail or a support ticketing system. It might also be not with customers, or it can also be with internal employees, like an HR department having to provide a lot of support about common questions that employees are asking. So when you're talking about service and support, those are a couple of examples. You could look towards data gathering, in-field data gathering, sometimes called inspections. So I have people working in the field gathering all kinds of data. Maybe that's something for AI to assist with. So either analyzing visual information, like we showed with the Loendersloot use case, that could also be applicable for a construction company, for instance, that needs to update the customer on the status of what he's constructing. We could like show an image to an AI and have it assess it like an architect or a building or a construction manager or whatever. Or we could have an AI look at some data from either a machine, like we discussed with Verhoeven, or some data we are seeing generated from an external party, or stuff like that. Then the third one is processes that have to do with data analysis or data processing. So sometimes you have people working in jobs that are getting in a lot of unstructured information, like emails, like documents, that are always in a different format. But we can instruct an AI to extract certain information from those sources and make structured info from it. So if we tell an AI, you behave like an arbiter of this information and make sure you get all these points out of that information, then we can, of course, store that information within an existing system that we already have. Like we also explained with Loendersloot, where the information is eventually saved in an ERP system. But on the other way, we could also say we're doing a little bit of data analysis with AI, where we connect the AI with a database. It be your CRM system or an ERP system or a ticketing system, where we want to ask concrete questions about maybe volumes of sales we made, volumes of sales we did compared to last week, where we traditionally needed a data analyst, for instance. We have use cases with knowledge management, where we can look at, like, is everything, all the knowledge we're building, is that still inside people, and is that shared enough between people? So most companies don't have a company wiki that's actively being maintained, but maybe there's an opportunity with AI to gather knowledge from all these employees and then make it accessible for anyone to be used in a similar case, or maybe even in a new case, to make that process more efficient and not reinvent the wheel every time at every customer. And then lastly, we could look at content creation, where we need to use our company context and a certain fixed process, like maybe sending newsletters every week that need to be personalized, or sending documents that need to be personalized. Can we do something in that area where we see potential time savings if we build a little generative AI machine that could do this process quicker with less input, or not even input, like do it autonomously? So I would say it's important to identify use cases within those areas first. Of course, there are a lot of other opportunities that you can look at with this technology, but once you identified those use cases, it's important to score them in terms of impact. So how much do they impact the business if we do this 5 or 10 times quicker, or maybe even more even quicker than that. Also see which effort it would be for the organization or an external party to build that machine for you. So of course, we'll first choose the use cases that have the biggest impact and require the least amount of effort when determining which use cases we should go for. And then after you've identified that use case, don't make a huge project from that, but first build a small proof of concept tool or have it built by someone that will show to all the stakeholders involved into that process what generative AI can do, also to inspire them to think along of how it can be further improved, but also show them the capabilities so they can come up with more ideas on their own, or maybe identify data gaps or which the AI still has data it needs to actually execute on that task with high accuracy. So these would be the steps we recommend to build your own AI solution. I don't know, Koen, do you have anything to add to this list, or
maybe
another best practice to share?
Maybe a bit on the assessing the effort side of an AI implementation, because it can be hard if AI is not your main topic to assess how hard it is to develop an AI application. And I think if you compare it to asking another colleague to perform a certain task, if I ask someone, hey, can you automate, can you take on this task? And this task is quite specific and doesn't have a lot of variables in play which can affect the outcome of the task, then that's quite easy to automate. And if you look at a task or a process where you need a lot of variables that affect the task and the outcome of the task, it becomes harder to develop such an application. So to assess the effort, you could say, okay, the easy task for a human are also easy to implement in terms of technology. And the harder it is for a human to perform, the harder it gets for AI as well. Certainly tasks where, for example, the holy grail of your company, if we can solve this problem, then we are X amount better than all our competitors. Those tasks are harder to, they take more effort to develop.
Yeah. So, yeah, a good note to end with, I think. Maybe if people are interested in learning more about this topic, so that's AI and applying it into your business, we'll be producing more of these videos. We plan on doing it weekly or bi-weekly. I would recommend you to follow our channels. So subscribe, like our content, and that will motivate us to do more of this. So usually we were kind of working in the background of our projects, but in the future we'll be sharing concrete examples, show you how certain AI agents are built. We'll keep you up to date on the AI news, so you never miss another opportunity on the AI landscape. And this is one of our first videos where we take you through the basics, but we'll produce a lot more of the content I mentioned. So please follow us, right, Koen?
Yes. Follow and subscribe.
Yeah. Okay. Until next time.
Yes. See you later.